friends. I am Satish Lele. I am a chemical engineer. I am working in field of piping for last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about detailed engineering. Some key issues are basic considerations, plant layout, layout in process units, layout of piping, utility layout and spacing, off-site facilities, flare, waste treatment facilities. Basic considerations: wherever explosion or fire hazard exists, proper plant layout and adequate spacing between hazards are essential to loss prevention and control. Layout relates to the relative position of equipment or units within a given site. Spacing pertains to minimum distances between units or equipments. For oil and gas, explosion hazard, fire hazard, proper plant layout, adequate spacing between hazard areas. Safety and environment: hazardous and flammable materials require special handling. Toxic chemicals need closed chemical sewers and other protection measures. Governing standards and regulation in plant sites should be followed. Initial capacity and future expansion should be considered. Multiple processing lines trained for expansion. Pairs of trains can either be identical or be mirror images. General guidelines are: the plant layout shall be arranged to maximize safety, prevent spread of fire, facilitate easy operation and maintenance, consider future expansion, economize project. Location and weather: the plant layout shall be arranged in consideration of geographic location and weather in the region of the site. Prevailing wind: where the prevailing wind is defined, the administration and service facilities and directly fired equipment, etc., shall not be located windward of process units and storage tanks, etc. Layout indication: the basic requirements to be met in the appropriate diagram when making the piping and equipment layout are: all equipment, ladders, structures, davits, trolley beams, shall be indicated. All instruments shall be located and indicated. All valving and handwheel orientations shall be indicated. Drip funnel locations for underground drains shall be indicated. All electrical switch gear, lighting panels shall be indicated. All sample systems shall be indicated. Area arrangement in plant layout has classified blocked areas, such as process areas, storage areas, utilities areas, administration and service areas. Location of process areas shall be decided on the basis of following factors: soil characteristics, main road, rail access ways, and jetty, location of pipeline to and from plant, direction of prevailing wind. Location of process areas shall also be decided on the basis of local law and regulation which may affect the location of units and storage facilities. Natural elevation for location of upstream or downstream units and equipment, such as feed and product storage tanks, wastewater treatment plant, oil and water separator. These are arranged as follows. The process area shall be located in the most convenient place for operating the process units. The units shall be separated by roads. Major roads shall have minimum width of 10 meters, with maximum length of 400 meters. The minor roads shall have minimum width of 6 meters. The storage area shall be located as far as possible from buildings occupied by personnel at the site, but should be located near the process area for ready operation of the feedstocks and products. The utilities area shall be located beside the process area for ready supply of utilities, except where they are an integral part of a process unit. Site utility units should be grouped together in an area classified as non-hazardous. Loading and unloading area shall be located on a corner of the site with capable connection to public road directly for inland traffic. Loading and unloading areas for road transport shall have adequate space to provide access for filling, parking and maneuvering. The drive-through rack arrangement is preferred. The loading and unloading facilities should be downwind or crosswind from process units and sources of ignition, based on the direction of prevailing wind. For marine transportation, the area shall be located on the seaside or riverside in the plant site. The administration and service area shall be located at a safe place on the site in order to protect personnel from hazards. It shall preferably be located near the main gate alongside the main road of the plant. Flare and burn pit shall be located at the end of the site with sufficient distance to prevent personnel hazard. Wastewater treating unit shall be located near at the lowest point of the site so as to collect all of effluent streams from the processing unit. The process unit to which the feedstock is charged first shall be located on the side near the feedstock tanks to minimize the length of the feed line. The process unit from which the final products are withdrawn shall be located on the side near the products tanks to minimize the length of the product run down line. Process units, in which large quantities of utilities are consumed, should be preferably located on the side near the utility center. In respect of security fence, all sides, Plan 4 complex, shall be within a security fence. The minimum space between security fence and unit's boundary shall be 20 meters, and between security fence and equipment shall be 30 meters. In case of special units such as flammable material storage with vapor release and toxic materials, minimum space shall be at least 60 meters from site boundaries adjacent to centers of population like domestic, work or leisure. Fire water pumps and equipment shall be sufficiently remote from processing, storage and loading areas. Where a major fire could occur, fire water pumps and equipment shall be sufficiently remote from processing, storage and loading areas. Where a major fire could occur. Roadway, road and access ways shall offer easy access for mobile equipment during construction and maintenance, firefighting and emergency escape in a fire situation. Access roads shall be at least 3 meters from processing equipment between road edges to prevent vehicle collisions. Pipe racks and sweepers. Pipe lines run overhead should be grouped in pipe racks in a systematic manner. Pipe rack runs oriented in the same direction shall be at consistent elevations. Pipe rack runs oriented opposite to these runs shall be at other elevations to accommodate crossing of lines at pipe racks junctions and to accommodate branch line intersections. Single-level pipe racks are preferred if more than one level is required. The difference between levels oriented in the same direction shall be adequate for maintenance, but not less than 1.25 meters. Maximum pipe rack widths shall be 10 meters. If widths larger than 10 meters are required, The pipe rack shall be designed to be of 2 stages. Actual width shall be 110% of the required width for the required width plus 1 meter. In cases where thin coolers are to be placed on the pipe racks, the pipe rack width shall be adjusted based on the length of the air coolers. Avoid flash turns. When changing directions, change elevation. Allow ample space for routing instrument lines and electrical conduit. Provide 25% additional space for future instrument lines and electrical conduit adjacent to that required. Provide 20% additional space on the pipe rack for future piping. This space shall be continued and clear on each level for the full length of the rack. The width allocation may be split into sections at not more than 2. Allow continuous, clear area of 4 meter high by 4 meter wide below main racks in process units for maintenance access ways. Pipe racks outside process areas shall have the following minimum overhead refinery or plant clearances. Main roadway, 5 meters. Access roads, 4.5 meters. Railroads, 6.7 meters above top of rail. Parts of detailed engineering are conceptual factory design, basic design, optimizing in-house engineering, value engineering, CAD for process plant, process specifications. Conceptual factory design. A professionally planned production facility is made up of many essential components: process, logistics, buildings. We first look at what is known as site understanding. This means analyzing the location, strategy, and interpreting it according to your standards and aims. The process engineers carry the responsibility and ensure that all planned processes can be implemented within the framework of a master plan, right through to the technical systems within the building. The areas are divided into a number of batteries with specification of battery limits. These can be process plants, utilities, tank, farm and loading, unloading, etc. Preparation of plot plan drawing. The general plot plan drawing shall give the layout of the whole plant. It should be prepared in accordance with one of the following scales. 1:2000, 1:1000, 1:500. The following items shall be shown in plot plan drawing. Battery limits of complex area boundary. Plant geographical and conventional north. Elevation. With regard to the nominal plant zero elevation. Coordinates of main roads. Process units, utility units, buildings, storage tanks and main pipe rack. Location of flares and burn pit. Direction of prevailing line. Plant coordinates may be started from point M equals 0 and E equals 0. On request, piping engineer may show 3-dimensional animation of future factory. He should work out required cost estimates to take decisions necessary to obtain clearance for investment. Basic design. Each new project could be compared to an organization where people and economic decisions take on evenly balanced roles. Area calculation, room design, flow of goods and staff, hygiene concept and validatable operation are some of the details need to be worked out. Added together they make up the complete story. Human factors add that indefinable extra as they are equally valued prerequisites for the success of the company. The scale of development will become ever more refined as the project progresses. Drawings on a scale of 1:100 show how functional areas will be used. They provide details regarding heating, ventilation and air conditioning, power supply, IT network. Equipment plans and specifications are produced and plans for the individual plant components are specified in more precise detail and documented. Once they have agreed together with clients, the plans have reached their optimal peak, they are now in the position to make an offer for the next stages on a turnkey basis. However, they should be completely flexible. It covers the principles and techniques which lead to effective and efficient engineering activities in a project environment. It examines the engineering organization and the elements in each phase of capital plant project design and engineering from concept through detailed engineering, stage reviews and client approvals, and engineering support during construction. Engineering and design schedule and budget considerations are reviewed. Optimizing in-house engineering methods and techniques for efficient and effective engineering decision-making and performance which take advantage of alternatives available to ensure optimum productivity and quality engineering. Course utilizes the analysis of experience on many projects and emphasizes efficient teamwork and coordination. Value engineering. It covers the purpose and principles of value engineering and methods for reducing overall project costs while maintaining or improving project value. Emphasizes the importance of attention given at appropriate stages in design, procurement and construction to eliminate unnecessary features, considers substitutes and alternates and optimizing costs while preserving the ability to construct the project. C and CAD for process plant engineers. Computer-aided engineering C and computer-aided design CAD can be used for project and process plant engineering and designing. Analytical comparison of both systems including experience with prominent basic systems for a broad spectrum of applications on actual projects. Provides basis for selection of appropriate software for project design and operation, and methods to make the use of computers fully effective. Process specifications. Structured approach to process specification writing, featuring methods and techniques for code and design practice compliance, optimizing heat and material balances, and developing efficient design parameters while ensuring the integrity of the process, minimizing utility costs and maximizing profitability. Block diagram is first step of development. It shows input and output streams for each unit operation. Plant layout is then done with respect to equipment nearby are mostly placed in line for easy flow of process. These can be layers at different elevations. Floor height per meter is generally considered